This is the derivation of the general formula when there's only one time-dependent capacitor in the circuit. So any circuit, whether it's complicated or not, can be reduced down to two elements, a VTH and an RTH, which is the Thevenin equivalent for any circuit. So if between the A and B points a capacitor element is placed, with a value of C, which will be in farads, there's the voltage across it, and then there's current going through the entire circuit, which is going to be I of t. A voltage loop can be taken. If I take it around in this direction, I have a plus here, a minus here, and a minus here. My equation will be plus VTH minus I of t RTH minus V of t equals 0. For a capacitor, it's known that I of t, which is the current going through it, is equal to the capacitor value dV of t over dt. So this can now be plugged in for the current I of t here. And it will be plus VTH minus V of t minus C RTH dV of t over dt equals 0. This can then be taken over to the other side, so it becomes a positive. And this can be divided here. So I get C RTH on the bottom. And now I can separate the variables here. I can divide the dt over to this side, and I can take the quantity with V of t in it and divide the dV of t with that. So that will be dV of t all over VTH minus V of t. And I want to make this positive, so I can take the positive, this will become negative, and this will make on the other side a negative dt over C RTH. I can then take the integral from t0 to t on each side of this. And recall that the integral of u, which is du over au plus b, is equal to 1 over a natural log of au plus b. And that will be evaluated from t0 to t. So in this case, A is a 1 and B is a minus VTH, and the U, which is the function, is voltage V of t. So that will give me one over A, which is 1. So 1 over A, which is still 1, natural log of A times U plus B, which is a minus VTH, and then a minus, again 1 over 1 natural log of VT0 minus VTH is equal to a minus T0 over CRTH, and this is because CRTH is a constant value. Also recall that natural log of A minus the natural log of B is equal to the natural log of A over B. So in this case, this is A and this is B. So I can combine these into the natural log of V of t minus VTH all over V of T0 minus VTH is equal to a minus T minus T0 all over CRTH. Now to get rid of the natural log, both sides can be raised to the exponential. This will cancel out here. I can then multiply this on each side. So I can take that quantity over here and multiply it. And then I can add this VTH so that I have the function form of just V of t is equal to something. So rewriting that, V of t is equal to plus VTH plus a V of T0 minus VTH e to the minus T minus T0 over CRTH. The general form is a final plus the initial value minus the final, e raised to the minus t naught over tau. So in this case, tau is CRTH. Our final value is VTH, and the initial value is V of T0. So you can notice here, just kind of checking this equation, if this has been sitting in this position for a really long time, there's going to be no change in dVt over dt, so that will become 0. So I of t, when it is 0, looks like an open. So if this becomes an open, there's no current flow here. And so the voltage between this point and this point will be just VTH. So that would be our final value, which you see it is here. VTH is our final value. VT naught, which is the initial value, is found dependent on just the initial conditions of the circuit.